Hello and welcome to the channel for chemistry revision. I know these are the exam times and one of the most tension times for all the students because it's the time for term and exams. So, what's going to be important for term and exams, guys? Term and exam revision. All right, so let's quickly start the topics for revision today.
Properties of suspension, solution and colloids, solvent, solute, dispersed phase and medium, different types of colloids, and electrostatic forces in colloids. Five main points we will discuss here in this presentation. Let's see the first one, comparing the properties of suspension, colloids, and solution. So what exactly these three things are? So let's understand, guys, that these three things are types of mixtures. So mixtures we use every day in daily life. Tea and coffee are mixtures. Salt solution is a mixture. Sugar solution is a mixture. Whenever you add two things, salt in water becomes a mixture. But mixtures are of three types depending on the particle sizes. So when particles are less than 1 nanometer, that type of mixture is called solution. For example, salt dissolved in water. Similarly, when particle size is between 1 nanometer to 1000 nanometer, that becomes a bit bigger particle size and we call it colloid. It's not a solution now, it's a colloid. Example is milk, blood, paints. These are the colloids. And then the third type is a suspension. Suspension, the particle size is even more bigger, and so it's so big that it can be seen clearly without a microscope by our eyes. For example, sand in water. So when we add sand in water, we get the suspension of sand, and the particle size of sand is more than 1000 nanometers. Now, these are some examples of colloids in daily life. Whipped cream is a colloid, guys. So it's like a good mixture of substances together. Then hair gel or toothpaste gel is also a colloid. Creams, the creams we use in cosmetic are oil in water colloids, and the creams we use in medical purposes are water in oil type of colloids. Next thing we have is some important uh, terms related to solvent, solute, and colloids. So, for example, if you are talking about a salt solution, the quantity which is more is called solvent. The quantity which is less is called solute. So, salt is the solute in a salt solution, and water is the solvent. Same logic applied to colloids. So the quantity which is more in case of a colloid is called dispersion medium, and the quantity which is less is called disperse phase in a colloid. Colloids in our daily life. So aerosol, when we fly in the aeroplanes, we see the clouds, aerosols. Those are colloids. The mist in the excursion areas and wadis. Whipped cream, we already spoke about it. Milk is an emulsion. Emulsion is a type of a colloid. Ink and mayonnaise is also a colloid. Now, very important objective we have today is the types of colloids. So there are three different types of colloids, guys, where the dispersion medium is liquid. So in the liquid, we can have solid disperse, for example, in Sol and ink. We can have liquid in liquid like emulsion paint, milk, and mayonnaise. We can have gas mixed in liquid in a colloid, and that is foam and shaving cream. Then we can have gas as a medium, a lot of gas, and inside the gas, liquid is dispersed. For example, aerosol and fog, mist, we already saw. And then smoke and ice clouds is solid dispersed in gas. The last one is liquid dispersed in solid, which is agar gel and gelatin. Let's go to the next important pointer, which is Tyndall effect and Brownian movement. Now, Tyndall effect is when the light gets scattered. When we put light on a colloid, you can see here one opalite crystal is taken, and when light is made to fall on this crystal, guys, the crystals of colloid they scatter the light. This scattering of light by the colloid crystals is called Tyndall effect. So remember that. And another property of colloid is a Brownian motion. So when colloid particles, they keep moving randomly in all directions. That's called Brownian motion. You must have noticed Brownian motion when there is sun, and in the sun you see the dust particles moving. So that's an example of Brownian motion. Last objective is the electrostatic forces. So now this is important, guys. Colloid particles are heavy and big because we said their size can range up to 1000 nanometer. So how will such heavy particles stay together in the medium? They will not settle down because of electrostatic forces of attraction, because these forces are due to the polar or charged atoms on the surface of the colloid. For example, the micelle formation. When we wash things with the soap, we have micelles formed, and those are the best example to explain how electrostatic forces hold the particles of colloid in it. If these forces are broken or stopped, the colloid gets dismantled and it settles down. So that's about it for today, and I'll try to put up more revision on this. Till then, keep revising and all the best.